First video for the Unit 3 practice exam. Number 1, the top of a mountain at the equator is 6,375 kilometers from the Earth's center. What is the tangential speed of this point? Great question. So here's the Earth, here's the equator, and the mountain is right here. And it says that the top of the mountain is 6,375 kilometers. So just add 3 zeros, so that's changing into meters. So the top of the mountain is that distance from the center of the Earth. So that's your R value. And the question is asking, what is the tangential speed? So the top of this mountain, the Earth is revolving around and around. The top of this mountain is going around there, coming back here. So top of the mountain is revolving. The question is, what is the period? Because to find tangential speed, we have to use this formula here. V equals 2 pi r over t. And just a reminder, that is simply a permutation of d. V equals d over t. But d in circles is the circumference of a circle. And the circumference of a circle is 2 pi r. So we have the radius. The only thing we need to know is what is the value of t, and t is simply the period of rotation of the Earth, which is 24 hours. All right, so that's the only difficult part of this question, really, is figuring out what the value of t is. And once you realize it's a mountain at the equator, then it's going to take 24 hours for the top of that mountain to return to the position from where it started. So 24 hours in seconds will simply be 24 hours times 3,600, because there are 3,600 seconds in an hour, and you multiply that out and you get 464 meters per second. Meters per second. So the answer is D. Oh, and it seems the test has the wrong units on D. So that should be, these all should be in meters per second. Number 2 says the outer rim of a turbine in a jet undergoes a centripetal acceleration of 1.85 times 10 to the 11 meters per second squared. If the period of rotation of the turbine is 1.2 times 10 to the negative 5, what is the radius? Okay, so let's write down what we have. We have the centripetal acceleration, 1.85 times 10 to the 11 meters per second squared. It says the period of rotation, so we have the t value, t 1.2 times 10 to the negative 5 seconds. And the question is asking, oopsie, we've got a meeting in a few minutes. The question is asking, what is the radius? The radius. So for this one, you have to go to your formula sheets and you have to find, there are 2 formulas for centripetal acceleration. This one here, and this one here. And obviously we're going to use the second one because we're given the period and the radius. Simply substitute those into sorry, no, we're solving for the radius. So let's actually do this. Let's manipulate the formula. R equals AC times T squared over 4 pi squared. And now you can substitute those 2 values in, and you end up getting an answer of 0.75 meters, which is C. All right, moving right along. Number 3, a ball travels in a circular path so that it undergoes a centripetal acceleration of 12.5 meters per second squared of magnitude. What is the radius of the circle if the tangential speed of the ball is 6.25? So in this question, they give us the centripetal acceleration. They give us the speed. So they're asking for the radius. They're asking for the radius, and they give us the velocity. And so as you can see, this is a really straightforward question. You can simply go to this formula right here. Solve for R. Plug in your numbers and get your answer. It's just going to be 6.25 squared divided by 12.5, and that gives you an answer of 3.4 meters. Okay, number 4. So this one, if a force of 56 newtons does work over a displacement of 24.5, so let's just write in, we're given force, we're given displacement. So right away, we know we can find work. If the angle between the force and the displacement is 35 degrees, so 35 degrees, what is the work done by the force? Go to our formula sheet, find the formula that has these variables in it. It turns out to be work equals force times distance times the cosine of theta. Because remember, if you're pulling something at an angle, if that's 35 degrees, and we're pulling this with 56 newtons, but the object is moving just in this direction, then only a portion of that 56 newtons is being used to actually move the object. So it will be 56 times 24.5 times the cosine of 35. Stick that into calculator, and you should end up with 1,120 joules, which is B. Number 5. Number 5 is a similar question. It's just in this case, they're asking, they give you the angle, a force acts at an angle, so they give you theta above the horizontal on a sled, and it moves 98 meters, so they give you the displacement. If the work done, so this time they give you the work, and I can already see this, the answers actually are wrong. The exponent in the answers is wrong, 2.8 times 10 to the 8 joules. What is the magnitude of the force? So same formula as the previous question, we're just solving for F. F equals W divided by D sine theta. Let's take the D and the sine theta, divide both sides, and so you're gonna, and then just plug in the numbers. I don't know why I wrote sine, it's cosine, oopsie. I know I did actually, it's because in physics 30, I'm doing a very similar formula that has sine, so sorry about that. It's cosine, lordy lordy. Cosine theta. Cosine. 28 degrees, stick in those numbers, and I'm going to get on my calculator because something is wrong with the answers on this question, it seems. 2.8 E 8 divided by bracket 98 times cosine 28 end of bracket equals, yeah, so it's 3.24 times 10 to the exponent 1, 2, 3, 4, 5, 6 to the 6. newtons. So this actually should be a 6. So the answer is really C. I think the answer, all these exponents should be 6. Anyway, hopefully you figured that out. Or hopefully you didn't spend way too much time trying to figure that out and got frustrated. Number 6, the total mass of the passengers in an elevator is 425 kilograms. If the elevator moves the passengers to a height of 50 meters, what is the change in gravitational potential energy of the passengers? That's a pretty straightforward question. All we want to know is EP. And since we're going to assume that they had no gravitational energy to begin with, it says the change in gravitational potential energy, which would be the EP final minus the EP initial. But we're just going to assume that the EP initial was 0, and therefore we just need to find out how much gravitational potential energy was gained when they went up 15 meters. So very simply, 425 times 9.81, no negative because energy is a scalar quantity, times 15, and that should spit out an answer of 6.25 times 10 to the 4 joules. B. Okay, let's get through 7 and 8, and then we'll stop this video and go on to the next one. A mass of 6.8 kilograms on a frictionless inclined plane is tilted at an angle of 42.8 degrees horizontal. How far along the plane have you pulled the mass when you have done 725 joules of work? Okay, this is a good question. I like this question. So we have 42-degree angle. And we're pulling an object up the surface, and it says how far along. So basically what we want to do is calculate this distance here. Have you pulled the mass when you have done this much work? Well, the question is, what kind of work have you done? 725 joules of work. What kind of work have you done? And the answer is this. I've moved it up from this position here to this position here. So it's gained gravitational potential energy. And so I can calculate how much energy. No, I can't calculate how much energy. Yes, I can. I can calculate what they've given me, how much energy it took. What I can do is calculate the height that it gained. So if I calculate the height that it gained, then in other words, I have this part of the triangle, and I have this angle, and then I want to find this part of the triangle, so I can just use trigonometry. So all I need to do is find out how much height it gained, and they give me what the gravitational potential energy, because that's the work. I'm moving it from the ground to a specific height, so it gained gravitational potential energy. Divided by the mass. Times gravity, you stick that into your calculator and you end up getting 10.8 meters. And then you can just, well, you can just put your 10.8 meters in here. And if 10.8 meters is the opposite in relation to this angle, and we're trying to find the hypotenuse, so then we're just going to use the sine function. And x turns out to be, what is it? 16 meters. 16 meters. Okay, actually, we're going to stop it at number 7, and then the next video will continue with number 8.